Good morning, Mr. This is here in a topic that is very popular in geometry, how to find the area of a regular polygon. Now, what you have to recall that a regular polygon is a polygon that is equilateral and equiangular, meaning that if it's regular, that it must be equilateral, meaning that all sides are congruent, and it must be equiangular, all angles are congruent. That is the definition of an equilateral of a regular polygon. So to be regular must be met those two criteria. First, it must be equilateral. Second, it must be equiangular, meaning that equal side, congruent side, and congruent angle. So we have a formula how to find area of regular polygon. It's 1/2 AP. A is the hypotenuse and P is the perimeter of the polygon. So to find the perimeter, it's P equal N times S. N is the number of sides, and S is one side. If you can know one of the side, you multiply by N. That will give you the perimeter. But there are other ways we can go and play with it and find the area. If it's an equilateral triangle, we can use the formula that we demonstrated earlier. That's 1/4 times S squared times square root of 3, where S is one side of the triangle. You square it, you multiply by square root of 3, divide by 4, that will give you one triangle. Then there are certain figures, you can make them create triangle. So if you can find area of one triangle and you multiply by the number of triangles that are created, because the triangle will be congruent. Now, we have a regular polygon. We need to find the area of it. So if we count how many sides, that will be 1, 2, 3, 4, 5, 6. That will be regular hexagon. So we will know hexagon. In this case, N is 6. That's the number of sides. So if we can find one side, we will be able to find the perimeter. And the hypotenuse is from the center of the circle, and that drawn perpendicular to the base. It's going to be a perpendicular bisector. So meaning this side will be the same thing as that side. In other words, we can make that create a triangle. Right? Then we can find this angle here, which is called the central angle. If we do this, you will create a bunch of triangles, 6 equilateral triangles. Right? That's one way. Now, I can also use, say if I take 360, find the central angle and divide by N. In this case, N is 6. That will be 60 degrees. So this angle will be 60 degrees. Since you create two triangles, this will be 30. 30. The central angle will be 60. Since they are equilateral triangle, all of the angle will be equiangular. Right? This angle will have been 120. So as you can see in regular hexagon, if you use the formula 180 times n minus 2 and divide by n, you will be able to find the interior angle in the regular polygon. In this case, we can define that the hypotenuse A is 10 square root of 3. Because it is given to you, drawn from the center of the circle and perpendicular to the base. This is how you find the hypotenuse. Now, you can realize also we create a 30, 60, 90 triangle. This will be the hypotenuse. If this is the hypotenuse, this is 20. For me to there will be half of the hypotenuse, which is 10. And this will be 10. this show you that the radius is 20, that radius is also is 20, this side is 20. That proves you it's an equilateral triangle, right? Where each side is 20. And I can show you various ways of finding the area. So in this case, we can find the perimeter. If n is 6, s is 20. Right? Now you find the perimeter is n times s. Now in this case, we'll have p is equal to 6 times 20. The perimeter will be 120. Right? We already know the hypotenuse is 10 square root of 3. And we know the formula to find area of regular polygon is 1/2 AP. So we find everything that we need to know to find the area. Right? Then we will say that A equal 1/2 A, which is 10 square root of 3, and P, which is 120. That will be the direct way of finding the area. As you can see, you can take half of 120, which is 60. And you will have A equal 10 times 60 is 600 square root of 3 square unit. That will be the area. Right? That's one way of finding the area of this triangle. The other way, since we do is create 6 equilateral triangle, I can find area of one of the equilateral triangle, right? Where each side is 20. Right? Then I can come here, use this formula. That's for one triangle. Then I have a total of 6. So I'll say the area equal 6 triangle times the area of one equilateral triangle, which is 1/4 times s squared. In this case, s is 20. N times square root of 3. Right? This will give you the same outcome. You will see how powerful math is. Now let's compute what here. Alright? Then you will have 6. 20 squared is 400. You will have 400, right? Square root of 3 over 4. Right? This can be simplified. 4 simplified by 400 is 100. Now 100 times 6 will give you 600 square root of 3 square unit. That will give you the same outcome. This is how powerful this section is. Right? Same outcome. Right? Since I know that a regular polygon will create 6 equilateral triangle, right? 6 equilateral triangle, I can use this formula. For an area of one triangle multiplied by 6 will give me the outcome. Let's say you did not figure it out this way. There go how powerful math is. I know I have a triangle. There's a boundary triangle that I pick. This triangle here. Right? The base will be 20. Right? Where we fit area equal 1/2 base times height. Right? In this case, your base is 20. The height, which is the hypotenuse, which is 10 square root of 3. I can find the area, this formula 1/2 base times height for one triangle and multiply by 6. And you are expected to get the same outcome. In this case, I will say A equal 1/2 base, which is 20, times height, which is 10 square root of 3. And remember, I have 6 of them. I'm going to multiply by 6. You are supposed to get the same outcome. So let's work inside. So you will have A equal for 6 triangle. Then you will take half of 20, which is 10. Alright, 10, then times that 10 by 10 square root of 3. Alright, we're gonna come here inside. That will be 10 times 10, which will give you 6 times 100 square root of 3. And if I take 100 square root of 3 times 6, it's going to give me 600 square root of 3 square unit. Either way, if you really know what you're doing, you should be able to figure it out. We're using the old formula as a right triangle, base times height, and divide by 2, and you will get the same outcome. This is how powerful math is if you follow those concepts. So either way, we're going to get the same outcome. We have shown doing that by using at least 3 ways. So we're going to come back and to find a couple one, and we move forward. Alright, you said this is back. Continue on how to find the area of regular polygon that is inscribed in a circle. So in this case, we have a regular polygon. So that's 1, 2, 3, 4, and 5. That's a regular pentagon. In this case, we know number of sides is 5, and this is from the center of the circle, and it is one perpendicular to one of the sides, and we know the hypotenuse is 15, and remember area equal 1/2 AP. Alright, where is the hypotenuse? P is the perimeter. So we need to find this side, one side of the triangle, so we can find the perimeter, then we can be in basis. So what we're going to do, let's see if we can create a triangle. We have this, we join this to that. This becomes the hypotenuse of the right triangle. Now, this is going to give you your triangle. That's one triangle. That's 2 triangle. That's 3 triangle. 4 triangle, 5 triangle. Those 5 triangles are congruent. So if I can find this side, so let me see if I can find the central angle, then that tells me what type of triangle that I created. If I take 360, I need to find the central angle divided by n. In this case, n is 5. Alright, calculator. You take your 360 to find the central angle. 360 divided by 5. That divided by 5. What is that? That gives me 72 degrees. Right? This central angle is 72 degrees. Now if I take 72 divided by 2, that will give me each angle. This angle will be 36 degrees. Right? And this angle will be 54. Each angle will be 108 degrees. So I have enough information. Right? So I can either use this angle here. My goal is to find one of this side from here to there. If I find it, then I can multiply it by 2. That will be one side. And once I know this side, then I can find the perimeter. So I can use trigonometric ratios. Right? The hypotenuse is not important for me. I don't need the hypotenuse. I need to find one of this side. I can either use the 36 degrees or the 54 degrees, either or. I'm going to use my 54 degrees as reference angle. Then this is going to be my opposite side, and this is going to be my adjacent side. Therefore, I can use tangent. So I'm going to use tangent of 54. Tangent of 54 degrees is equal opposite over adjacent. That will be 15, and over adjacent, I need to find the adjacent. Alright. Need to find that little x here, or you can call it x. Alright. So I can let's call it x instead. I can multiply both sides by x. This x will cancel. Then I will have tangent of 54 degrees times x is equal to 15. Then divide both sides by a tangent of 54. Then I will have x equal 15 divided by a tangent of 54. By this tangent of 54, you put 54 degrees and you press tangent. It's give me 1.37638.192. I'm gonna use everything so I can get an accurate answer. So you have 15, you divide by 1.37638.192. That's telling me this is 10.89813792. This only from here to there. So I need the entire side. I'm going to double it. If this is x, this is x. That's going to give you 2x. So we find x is going to multiply it by 2. That will give you this side. In this case, each side of the triangle gonna give you this triangle. The base gonna give you 21, meaning from E to D. ED is 21, 7, 9, 6, 2, 7, 5, 8, 5. I did not found it. So since I know what this S is, this is S. We find side. Right? Side is 21, 7, 9, 6, 2, 7, 5, 8, 7, 5, 8, 5. Now I can find the perimeter, then I will be in business. Alright? Meaning that the perimeter will be 5 times that. P, remember, for regular polygon is P equal n times S. So we're going to find the perimeter, which is 5 times 21, 7, 9, 6, 2, 7, 5, 8, 5. Multiply this by 5. It gives me perimeter is 108, 98, 13, 792. Then I can find the area. So my area is going to be 1/2. Alright. My A was 15 and my P is 108, 98, 13, 792. Multiply by 15 and divide this by 2, and this will tell me the area is equal to 817.603,443. Let me double check that. Alright, 108.9813,792 times 15, divide by 2, and that exactly that. Remember, it's area, you must put it as square unit. That's one way. The other way, since I have 5 of them, this is my height. My height is 15. My base is 21.79627585. I can find area of one triangle, 1/2, right, times the base, which is 21.79627585. Alright, times my height, which is 15. Since how many triangles I have 5 of them, and multiply this by 5. This should give you the same thing also. Then you will have 15 times 5, that's 75, times 21.79627585, and you take half of that. Bingo, it gives you the same outcome. So that has to tell you how powerful math is. 3603 square unit. Alright, we're going to take a break and perhaps analyze what we had just did, and you need to remember those little concepts, how to find area of a regular polygon. This is a nice topic because it's when you think that we have learned in the past. Sometimes you have to use trigonometric ratios, but in this case, it was not created a special right triangle, it's just a simple right triangle. So I find the central angle. That's one way. Take 360 divided by n. Since this angle is 2 of them, divide by 2. So I find that to be 36. If this is 36, this has to be 44. That's also apply triangle sum theorem, and bang bang. So this is how powerful math is. So let's take a break. We're going to come do a couple more. Alright, Mr. This is back in how to find the area of any inscribed equilateral polygon. So remember, in order to be a regular polygon, it also has congruent side and congruent angle. Since in this example, it's in an inscribed regular polygon, we are dealing with an equilateral triangle. So we have option. We can either use this formula, which is 1/2 AP. Remember, A is you are putting always from the center of the triangle and perpendicular to the base. It's a perpendicular bisector. So we know what A is. A is 6. Alright? So since this is 60, this will be 30, 30. So we're dealing with the 30, 60, 90 triangle. The hypotenuse is the short leg. The hypotenuse is 2 times the short leg is 12. So EB will be short leg times square root of 3. Therefore, EB is 6 square root of 3 and EC is 6 square root of 3. Therefore, CB is 12 square root of 3. That's one of the side. S is 12 square root of 3. We can find the perimeter. So the perimeter, and N, in this case, N is 3. N is 3. So we can find the perimeter, which is NS, which is S times 3. That gives you 36. 3 times 12 square root of 3 is 36 square root of 3. So we know the perimeter, we know the hypotenuse. We can use the formula to find the area, or we can go directly use the formula. We're going to do it both ways to see how powerful math is. So area will be equal 1/2 A, which is 6, the hypotenuse is 6, and P, which is 36 square root of 3 square unit. So we just have to compute that and find the area. In this case, we're going to take half of 6, which is 3. 3 times 36, which is 108, times square root of 3 square unit. This is the area. Unless you want to change that to decimal. Right? And the other alternative, we can use 1/4, since it is an equilateral triangle. You can use this formula. Right? Area equal 1/4 is to divide by 4. S, which is 12 square root of 3, then you're going to square that. 12 square root of 3 squared and times square root of 3. This will give you the same outcome. In this case, we need to simplify that. We will have over 4, that's 1/4, 12 squared, which is 144, square root of 3 squared, which is 3, times square root of 3. Now we have to simplify that. How many times there's 4 goes to 144? This is 36 times. 36 times 3 is 108, square root of 3 square unit. Bang bang, same outcome. Right? Math is fun as long as you know what to do. Alright, we said this is his back. We have a square that is inscribed in the circle. A square is a regular polygon. As you know that it has 4 congruent sides and 4 right angle. Then, in this case, the hypotenuse is given to you. We know the hypotenuse from the center and perpendicular to one of the side. In this case, A is 4 square root of 2. Then this is the right triangle. We can use Pythagorean theorem to use that. But you have to realize it's a 45, 45, 90. You don't need to do that. If you use Pythagorean theorem, it will not take you more time, but it will give you the same outcome. So this side has to be 2 equal to that side. The diagonal will change that to 45, 45, 90. Therefore, this is 4 square root of 2. DF is 4 square root of 2. EF is 4 square root of 2. That gives you this side of DE, which will give you 8 square root of 2. Since it is square, that if this and it's a regular polygon, this side is going to be 4 square root of 2. We're going to give you 8 square root of 2. And there are many ways you can find the area. You don't even need to use this formula or any the formula, since it's a square, is length times width or size squared. So one way you can find area of a square is S squared. Alright, so I'm going to justify it either way to see that's a powerful math. It's depending how you say it. So I could find the area by a square root of 2 squared, which is time itself. And I'll give you the area that will be in square unit. That would be the easiest way to solve this problem. Since I'm giving you many ways, then I'll give you 8 squared. That will give you 64 times square root of 2 times square root of 2, which is square root of 4. Square root of 4 is 2. That will give you 64 times 2. That will give you the area. The area will be 128 square unit. Alright? The other alternative is to find the perimeter. Right? Since one side is a square root of 2, to find the perimeter, you will have to multiply this by 4. P will be 4 times 8 square root of 2. Then the perimeter will be 32 square root of 2. Since you already know what A is, then we know P, which is 32 square root of 2. Then we can use this formula, area equal 1/2 by the hypotenuse, which is 4 square root of 2, times the perimeter, which is 32 square root of 2. As you can see, you can simplify this. This is going to give you 2. 2 times 32 will give you 64. And square root of 2 times square root of 2 is the square root of 4. Square root of 4 is 2. And you will have 64 times 2, which is same thing, 128 square unit. Either or you get the same outcome. Alright? That was Mr. Disease in how to find area of regular polygon. So if you know your craft, you practice it, you will get the outcome. So be aware of that. Math is powerful as long as you know what you're doing. So since I realized that with 45, 45, 90, I take the shortcut instead of using the Pythagorean theorem, which would have taken me more time. Since the hypotenuse bisect is the perpendicular bisector of DE, and if this is 4 squared, DF is 4 squared of 2, F has to be 4 squared of 2. If you double that, that will give you 8 squared of 2. That will be this side of DE. Since it's a regular polygon, each side has 8 squared of 2. And multiply that by 4, we'll get the perimeter. Since we already knew what the hypotenuse was, 4 squared of 2, then we can find the perimeter, and we have those information. You insert that here. And that's what we did here. Since also we know it's a square, how to find area of a square is S squared. So a square root of 2 times square root of 2 will give you the area. Either way, you will get the same outcome. That was Mr. Disease in how to find area of regular polygon that is inscribed in a circle. Peace, practice, do some work, and those are the kind of questions you should be ace in the PSHC or SHC, OCC, and go get the grade. That was Mr. Disease. Just study, share, and like.